Let's go back to a problem we've already seen. What's the Taylor polynomial for log x focused around x equals 1 or c equals 1? We already got this, so you can look back at the other video. That's not the big question here. The big question is, how good is this? Let's go take a look in Desmos. All right, here we've got log x. I've chosen the point 3, x equals 3, even though our series is centered around x equals 1. It should be exact right at x equals 1, so that wouldn't be any fun. Let's try 3. I've got a formula for taking the nth polynomial here. So if I say p of x comma 1, that would be the first order Taylor polynomial, which is our linearization or tangent line. P of x comma 2 is like that. P of x comma 3, that's looking like a cubic, right? There's a fourth power and fifth power. And we said before, you know, it's getting better right around here, for example, where this is curving more and more and keeping right near that that function as it shoots down to negative infinity. What's happening over here? So at like 1.5, we're getting closer and closer there. But let's look at 3. What is our linearization, our first order Taylor polynomial here at 3? We're getting basically a value of 2 when log is actually 1.09 at 3. So, you know, it's kind of far off. But then let's try a second order polynomial. We're actually a little bit farther away than we used to be. And then here we're even farther up than the tangent line was. And we can actually keep track of all these. So these are all at x equals 3 with higher and higher orders. And you can see we started at 2 and went to 0, then 2.6, negative 1.3. And like now we're below 0. That's not good. And then way up at 5, then negative 5. So the answer at x equals 3 is getting worse and worse the more polynomial terms I add on there. We can try something fancy here and say like 1, 2, dot, 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 10. And that shows us the polynomials of order 1, 2, 3 up through 10. And here was the second order, here was the first order. But the higher and higher order it is, the more curved this gets and the larger the value at 3, which means we're getting worse answers. So apparently we can't trust this Taylor series for log with a value of c equals 0 to give us good answers at x equals 3, which is kind of disappointing. Let's go write that down. So we said p sub k at 3, x equals 3, gets worse and worse as we increase the number of terms. So we can't trust the Taylor polynomials when c equals 1 at x equals 3. This is for a natural log of x. Well, darn, this whole Taylor polynomial thing seemed like a great idea, but now it turns out sometimes it's good, sometimes it's not. Let's try another one. Let's do a Taylor polynomials for 1 over 1 minus x. That might not be the most interesting function right now, but we'll see it happen more often. Let's see where we can and can't trust that. So here we've got our main function 1 over 1 minus x. I'm going to do a Maclaurin series, so just using c equals 0. Here we've got our tangent line. That seems to be working okay. This is actually the Maclaurin series. There's no factorials, no minuses. It's really interesting that just this is basically 1 plus x squared plus x cubed plus x to the fourth, etc. Here's our tangent line. Here's our second order, third order, fourth order, etc. Let's put in a bunch of orders there. Hopefully that will wake up. Sometimes it takes a while to realize what's going on. Let's try it again. There we go. So the curve is getting closer and closer to the line over here, but it doesn't seem to be getting close to the line over here. Like that's the second order, that's the first order, but then third order, fourth order, etc. is up here. And if I look at the value at x equals -2, that would be over here. As we increase the number of terms, the answers we're getting just seem to be oscillating positive and negative and getting bigger and bigger. So again, this is a Taylor series that's pretty good in this region, but is not trustable at all out here. So we can't trust it. Actually, we saw it at -2, but it turns out you can't trust it below x equals -1. And so this isn't just the fault of log. Like, we might be willing to say, well, log is just different, but there appears to be other functions where you can trust the Taylor series polynomials in some places but not others. And so what are we going to do about it? Well, chapters 8.1 to 8.5 help answer where can you trust a Taylor polynomial and where can't you. Or you could say, how far can you trust a Taylor polynomial? They also answer some other questions that are important in different fields of math, but this is kind of our big motivating question. Taylor polynomials seem so helpful because you just get a nice polynomial approximation to any yucky function, but apparently you have to be careful about how far you can trust it. So on to chapter 8.1.